welcome to your class 10 mathematics NCERT or CBSE syllabus triangles chapter. In our last session we have completed up to 2 exercises. Now in this session we are going to start 3 theorems. Only 3 theorems will be done, which is very important for you. Okay, so what are the 3 theorems here, children? First one is angle similarity criteria, and S similarity means side similarity criteria, and one more SAS theorem. What is SAS here? Side angle side. Okay, these 3 similarity theorems we are going to prove in this session. So, by the way, what is criteria? Criteria means standard which is established as a judgment or decision. Especially for scientific one, this can be made. So, here we are going to start with the first theorem, that is Theorem 2.3. So, what about 2.1 and 2.2? 2.1 is a basic proportionality theorem or Thales theorem, and 2.2 is converse of BPT, and we have seen some of the corollaries, right? So now we are going to start our theorem with a statement. So look here, children, every theorem 5 steps are compulsory. What is that? Statement, data, construction to prove proof. What is the statement? If in 2 triangles, every word we split here. 2 triangles, see here, I am going to consider 2 triangles here. They look similar, but were they really similar? What is the rule, children? You should know. If they are similar, their corresponding angles must be equal and the sides must be in proportion. So the same thing we need to prove here. But in this theorem, corresponding angles are equal given. Let's read the statement. Corresponding angles are equal. If in 2 triangles, corresponding angles are equal, then which type of a triangle it is? It is an equiangular triangle. Okay, if 2 triangles, corresponding angles are equal, then we call them as an equiangular triangle. Then their corresponding sides are in the same ratio. Then their corresponding sides are in the same ratio or proportion, and hence the 2 triangles are similar. So here you have to understand the statement carefully. Given data, only first line is given data, and rest of the lines you need to prove them. So what they have given, corresponding angles are equal. What we need to prove, corresponding ratios are in proportion. If they are in proportion, we say that the 2 triangles are similar. Okay, let's start here. So we start with the data. What is the data given here? In your textbook, children, they have considered 2 triangles. See here, no need of by-hearting these triangles also. As you wish, you can take triangles of your variables or any letters you can take. Okay, so you may take this triangle big, that triangle small, like that also you can take, but understand the concept carefully. So I have taken 2 triangles. So data given, any 2 triangles set given. So we have taken here given triangle ABC and triangle DEF. In this, what they have given, corresponding angles are equal. That means angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. This is the meaning for corresponding angles. Now coming to your construction. Did we do any construction? Yes, we have done. What is that construction here, children? Mark a point P on DE such that, how you need to mark? you have to mark a point on this triangle P. How you need to mark? Such that this length must be equal to this length. That is, AB is equal to DP. Okay. Then one more point we need to mark. What is that, children? Same manner, mark a point Q on, what is that side? DF, such that, what you need to write here? Such that AC is equal to DQ. So once again, mark a point P such that this length should be equal to this length. And mark a point Q here such that this length is equal to this length. And now, one more line, what you need to write here? Join PQ. Join PQ. Next, what I need to prove here? Ratios are in proportion. See here, children, ratios are in proportion said. Any type of ratio, small triangle by big triangle or big triangle by small, you can prove. So let me take here AB. What is the corresponding side? That side DE is equal to BC. Can you observe on the figure? BC by EF is equal to CA by FD. See here, always if you are going in this pattern, you have to go other triangle also this pattern. Suppose if I say AB, don't say ED. AB by DE, BC by EF, CA by FD. Okay, don't change any letters. Okay. So now, how do we start our proof? So, how do we start here, children? How can I prove they are in proportion? So, I'm going to give you a hint first. So, how we are going to give? I'll give you an idea. So, now, what we know, children, angles are equal. So, we have taken such that this is same. We are going to prove congruency here. Do you remember the postulates what you have learned in your previous classes? So now, so this angle is same, this angle same, and this side is same. How? By construction. We have done the construction in such a way that this equal to this and this equal to this. Look here, AB is equal to DP and AC is equal to DQ. Yes or no? So side, angle, side. Side, angle, side. Then the two triangles are congruent. Do you know what is CPCT? Corresponding points or corresponding parts of congruent triangles. By CPCT, what you can say? So if these two triangles are congruent, if you are able to prove, already we had proved by SAS postulate, right? Then these angles are also equal. Okay, so if they are equal, what can I say? Observe the point here carefully. First, given data, angle B equal to angle E. Now by CPCT, what I can say? Angle B is also equal to angle P. Then look here, the angle B is common for these two equations. So directly you can equate angle P is equal to angle E. That means corresponding angles are equal. Yes or no? So one above the other, corresponding angles are equal. Then the lines are parallel. If they are parallel, what you can say, children? The ratios are in proportion. Equate this ratio here. DP by DE is equal to PQ by EF is equal to DQ by DF. But in the place of DP, you substitute AB. Okay, so just a hint I gave you. Let's start the proof. So here, how do we prove here? Consider triangle ABC and triangle DPQ. Consider triangle ABC and triangle DPQ. So now, what's the given data? You know, right? So in that all the three angles are equal. So while I am proving, I'll consider the above two triangles here, children. And then I say here, angle A is equal to angle D. Why big angle I have written here? The concept you need to observe is only the middle letter. Okay, angle A is equal to angle D. Yes, so first write this letter, then write the other two letters, right? Angle BAC, then this one will be angle PDQ. Okay, so how it is? Reason you have to write now? By given. So now next, AB is equal to DP and AC is equal to DQ. How children this one? By construction. By construction. We have done the construction such a way that these two are equal. So now what I can say here? Triangle ABC is congruent to triangle DPQ. Do you know the congruency symbol? That will be SAS postulate. How did we prove they are congruent? Due to side, angle, side. By SAS postulate. So one more thing you need to observe when you are proving SAS postulate. What happens, children? Angle should be included between two sides. Okay, suppose let me take these two sides. Okay, the angle if it is here, you cannot prove. The angle must be included in between the two sides. Then only I can prove SAS postulate. Side, angle, side. For another corresponding triangle, side, angle, side. If they are same, then I can say those two triangles are congruent. If they are congruent, what can I say, children? They will be similar. Only the top two triangles. Okay. So now, by CPCT, what can I say? If two triangles are congruent, then you can equate other angles and other sides are also equal. So children, understand here. So first let me show you shortcut, then you can write full form. So now what I need? Therefore, angle B is equal to angle P. Observe here carefully. Angle B is equal to angle P. How you are saying this? By CPCT. What is CPCT? Corresponding parts of a congruent triangle. So now congruent triangles. So now, but what is given here? Angle B is equal to angle E. Angle B is equal to angle E. Now compare these two angles, children. These two are common, no? So directly you can equate these two. How we are going to equate here? Angle B is equal to angle P. Angle B is equal to angle E. On comparing, compare these two. On comparing, what you can write here? Angle P is equal to angle E. This equal to this and this equal to this. How you are saying this? By given data. By given data, angle B is also equal to angle E. Therefore, angle P is equal to angle E. Observe here, children. Now the corresponding angles are equal. Then the lines are parallel. Therefore, corresponding by axiom 1, children, do you remember? If corresponding angles are equal, corresponding angles are equal, then the lines are parallel. What are the lines here, children? What are the lines here? PQ is parallel to EF. PQ is parallel to EF. Now again, what do you remember? If lines are parallel, you remember BPT, right? So, if lines are parallel, you may apply any corollary. I'll apply. Okay, in order to compare this, I can't apply PPT or I can't apply corollary 1. Either corollary 2 or corollary 3 you can apply. So now, by corollary of BPT, what can you say here? I just compare this with dP by dE is equal to PQ by EF is equal to QD by FD. So finally what you can say here children, DP is also equal to AB, right? So in the place of numerators I am going to apply this triangle sides, that is AB by DE is equal to BC by EF is equal to CA by FD. Hence, it is proved. What is this children? It is how it is proved. So, if the ratios are in proportion, look here, angles are, corresponding angles are equal given. Therefore, what you can say? Ratios are in proportion. If they are in proportion, therefore the two triangles are similar. Okay, this is your angle similarity criteria or AAA similarity criteria. Both will come under same. Okay, now let's see the next theorem children. It's your theorem 2.4. What is this theorem? It is SSS similarity criteria. SSS criteria or similarity criteria. So here, what is the statement here children? What do you mean by SSS here? Side similarity criteria. What is the statement here? If in two triangles, can you see the two triangles? Yes, ABC triangle and DEF triangle. Sides of one triangle, what children here? Sides of one triangle are proportional to the sides of the other triangle. So, this triangle have three sides AB, BC, CA, and this triangle have three sides DE, EF, FD. These sides are proportional to these sides. So, two triangle sides are in proportion given. So here, then their corresponding angles are equal and hence the two triangles are similar. So observe here carefully children, they have given only the two triangles ratios are in proportion. What we need to prove? We need to prove that their angles, corresponding angles are equal. If it satisfied that rule, then we can say those two triangles are similar. Okay, this is called as the statement given here. We start a theorem proof with 5 steps. You know, no children, what is that? Statement given. Okay, statement is your first step. Then what's your second step? It is data. What is your second step here? Given data. What is given? Given ratios are in proportion. Given for the two triangles, ratios are in proportion. Given in triangle ABC and triangle DEF. Look here, triangle ABC and triangle DEF. The ratios are in proportion. Okay, they have given two triangles. Given in triangle ABC. Okay, cut. Okay, given in triangle ABC and triangle DEF, the ratios are in proportion. What are the ratios here, children? AB by DE. See the ratios, children? AB, BE, BC, EF, CA, FD. AB by DE is equal to BC by EF is equal to AC by DF or CA by FD you can write. So here when we need to prove, we take any two ratios and we prove here. So now look here, what is the construction we are doing here? We are going to do a small construction here. Construction. What is the construction we are going to do? Mark a point P. Mark a point P on DE such that DP must be equal to AB. Okay. and mark a point Q on DF such that AC must be equal to DF. Then join PQ. Okay, this is the thing I have done in construction. So now let me mark that. Mark P on DE and Q on DF such that, how we have marked here children, such that AB is equal to DP and AC must be equal to DQ. Okay, the next step, join PQ. Okay, now what we need to prove here, TP to prove. What we need to prove here? The corresponding angles are equal. What are the corresponding angles for the two triangles here? Angle A is equal to angle D and angle B is equal to angle E. Angle C is equal to angle F. Finally, what can I say here? If these two are all equal, therefore triangle ABC is similar to triangle DEF. This is the thing I need to prove here. So let us start the proof. One thing you understand here, what is that children? So if ratios are in proportion, you will prove that angles are equal. If angles are also equal, then the two triangles are in similar. Both are similar. So you need to prove this. How can you prove? So let's have 2 minutes here. Look here. Let's see 2 minutes how we can prove this theorem. So here AB by DE, BC by EF, AC by DF given. So you have taken that AB is equal to DP, AC is equal to DQ. Now how can you prove that? Given ratio you know. So instead of AB, you write DP by DE, DQ by DF you wrote. Okay. Now your next step, you need to prove here BPT. Now what you got is corollaries, right? So direct using BPT we are going to prove this theorem. So in order to do that, what we need to do? Do the corollary reciprocal and subtract 1. How do we get corollary? BPT add 1 we got, right? Now again reverse order. Same ratio you take. Do the reciprocal, subtract, you are going to get BPT ratio. After getting your BPT ratio, if your sides are in proportion, then the two lines will be parallel. If two lines are parallel, corresponding angles are equal. So if these corresponding angles are equal, what can you say children here? Then this angle is equal, then this angle is equal to B also. Therefore, if angle P equal to angle E, angle P equal to angle B, at that time you can skip the common angle such that angle B equal to angle E. Similarly, angle C is equal to angle F, angle A is equal to angle D. Finally, angles became equal. Therefore, the two triangles are similar. Okay, let's start the proof here. Proof. So how do we start proof children? Given what's the ratio? I will take in that ratio only sides ratio I'll take. AB by DE is equal to CA by FD also you can write, or AC by DF also you can write. There is no controversy in it. AC by DF. Okay, now I have taken only two ratios. I just kept this ratio. I am going to take only these two ratios while I am proving here. Now, we know, what do we know here children? By construction, we know, what is that we know here? AB is equal to DP. And what is that? AC is equal to DQ. AC is equal to DQ. Now in the place of AP, substitute DP, and in the place of AC, substitute DQ. So AB place what you need to write? DP by DE is equal to, in the place of AC, dq by df. Okay, so now what? See here, dp by de, dq by df you got. Now do the reciprocal here. So look here carefully, do the reciprocal. I am dragging your theorem this side. Do the reciprocal. What you are going to get here? This ratio, write it in reverse. de by dp and df by dq. Why I am doing this? I have said, no children, I will do the reciprocal and subtract 1 on both sides. So look here, doing the reciprocal of the ratio and subtract 1 on both sides in order to get BPT ratio. Okay, do the LCM children. DE minus DP by DP is equal to DF minus DQ by DQ. Okay. So now DE minus DP. In DE, if you remove DP, what you are going to get? PE. Yes, are you getting here? In DE, if you remove DP, you are going to get PE. So I write it as PE by DP is equal to, again look here, in DF remove DQ. In DF remove DQ part, what you are left with? QF by DQ. In your textbook, if you see, direct ratio is there here. So now again do the reciprocal. What you are going to get? Again reverse this. Okay, that means dP by PE is equal to dQ by QF. So dP by PE is equal to dQ by QF. What you will remember here, children? By the converse of BPT. Now what do I got here? Ratios are in proportion. By converse of basic proportionality theorem, if these ratios are in proportion, the two lines are parallel. Which two lines? PQ is parallel to EF. By converse of BPT, the ratios are in proportion. Therefore, the lines are parallel. Okay, if they are parallel, what can you say now? Given ratio, the two triangles are congruent. Okay, how can you say congruent here, children? Angle P, if two lines are parallel, then the two corresponding angles will be equal. If these corresponding angles, what are the corresponding angles here? Angle P is equal to angle E and angle Q is equal to angle F. Observe here, angle D is equal to angle D, common angle. Angle P is equal to angle E, angle F. Q is equal to angle Q is equal to angle F. So by this, what can I say here? Triangle DPQ is congruent to triangle DEF. Triangle DPQ is congruent to triangle DEF. So now I can write the ratio. If they are congruent by CPCT, what can I say here? Other ratios, that is dP by dE is equal to dQ by dF. We got here dQ by dF. These two triangles are congruent. That makes dP by dE is equal to dQ by dF. That is also equal to, all the three sides are in proportion, right? One more new side is PQ by EF. Okay, once have a look here, children. Let's change this ratio. What is dP? dP is nothing but AB. So let's rewrite here. AB by DE is equal to, what is DQ? AC by DF. And what is the third side? BC by EF. Then if these two are congruent, you can equate with this two sides and the third side also will be equal. That is BC by EF. Now compare these two here, children. Remaining all are same. Then when we compare this, we are going to get PQ is also equal to BC, or PQ is equal to BC, or BC is equal to PQ. Then finally, what can I say here? Triangle ABC is congruent to triangle DEF. When these two triangles are congruent, then the corresponding angles must be equal. That makes angle A is equal to angle D, and angle B is equal to angle E, and angle C is equal to angle F. Therefore, the two triangles ABC is similar to triangle DEF. This is your SSS criteria, children. Once again, have a look here. This theorem is also important. So, two triangles are given, then their corresponding sides are in proportion given. Make the two triangles similar. How you can prove? By making the corresponding angles equal, you need to prove this. So, we have started our proof by considering the given ratio. Okay, so we have done a construction. PQ is a line drawn on DE and DF. Okay, such that mark P on DE and Q on DF join PQ. So next what we have done, we need to prove that these two triangle angles are equal. So then we can say the two triangles are similar. We started our proof by taking any two ratios. I have taken AB by DE is equal to AC by DF. We know, what do we know here? We know AB is also equal to DP and AC is equal to DQ. Instead of this ratio, you can change the ratio. Then these ratios are equal, we have equated. Then directly I can't write this step. How you got this step, you should know. So what did I do? Do the reciprocal of the ratio, subtract 1, we are going to get BPT. Okay, and again by converse of BPT, I can say that if ratios are in proportion, then the two lines are parallel. So now if these two lines are parallel, then the corresponding angles are equal. If corresponding angles are equal, what you remember? The small triangle and the big triangle are congruent. If these two triangles are congruent, they are similar. So finally, I need to prove with this triangle and this triangle, I need to prove similar. But now what we have done up to here, we have done these two triangles are congruent. Now rewrite the ratios, that is dP by dE, dQ by dF. So now what we have taken, original ratio what given, that we have taken dP by dE and dQ by dF, whereas PQ by EF. We are comparing the two triangles. If they are congruent, then their sides are in proportion. So that I have written here. Instead of PQ, other two sides we have equated here, AB by DE and AC by DF. When we compare, automatically this ratio BC by EF is also equal to PQ by EF. On comparing these two ratios, we get PQ is equal to BC. If PQ is equal to BC, what you can say here, children? Then the two triangles are congruent. Which two triangles are congruent? The small triangle is congruent to this and this triangle is congruent to this. Finally, this triangle is congruent to this big triangle. Then when they are congruent, you can equate their angles and say the two triangles are similar. Okay, let's see the last theorem in this session. That is your Theorem 2.5. If one angle of a triangle, let me take angle A, angle D. Okay, if one angle of a triangle is equal to one angle of the other triangle and the sides including these angles. See here, children, I have said for you what is the included angle. If these two sides, then this angle we call it as a included angle. Same manner, this angle, included angle, right? Then what are the sides? AB, then DE, AC, DF. What is this? These are the two sides. Okay. These including these angles are proportional. Then the two triangles are similar. So what you need to show here, children? You need to show that if this angle for the corresponding one more triangle angle and the two sides including this angle are proportional. So what did they give here? Side, angle, side. Side, angle, side. SC is similarity criteria you need to prove here. So how can you prove? They have given a pair of ratio and angles given. So you need to prove these two triangles are similar by using this side, angle, side. So let's start here. What we are going to do here? Data. The two triangles are similar, you need to prove, right? Data. What is the data given? In triangle ABC and triangle DEF. Okay. What did they give here? Angle A. What is this angle A? Angle BAC is equal to angle EDF. And the ratios. What are the ratios given? AB by DE is equal to AC by DF. Okay, these are the ratios given. And what the construction we have done here? Construction. Mark a point P on DE and Q on DF. Join PQ. Join PQ. Okay. Now next step. What to prove here? We need to prove that triangle ABC is similar to triangle DEF. So now let's start our proof here. So children, observe here. Proof is similar to what we have done before. SSS criteria we have done. Similarity criteria we have done. Same manner you can prove this. So how to prove? Let's see in the figure here. So now given this angle equal to this angle and this side equal to this side and this side equal to this side. So complete side ratio they have given. But we have marked a point such that, what is that? DP is equal to AB and DQ is equal to AC. Like this we have marked a point such that this length is equal to this length. Okay. So now how to prove this? First we are going to take these ratios what they have given. In your last theorem how we have done, children? We have substituted AB plus DP and AC plus DQ. Then we have taken these two ratios. And further what we have done? We have done the reciprocal subtracted one and we have got the basic proportionality theorem, right? And then applying converse of BPT, what did we get here? These two lines are parallel. If they are parallel, then the corresponding angles are equal. Then these two triangles are congruent. Then finally what you can say, children? This triangle is also congruent to this triangle and this is congruent to this. This is congruent to this. Finally, ABC triangle is congruent to triangle DF. Then if they are congruent, they will be similar. Okay, like this we need to prove. So here, how do we start here? We start with the given ratio. AB by DE is equal to, what you have there? AC by DF. Okay, and the included angle is equal. So now what I have taken? Only the ratio. Then instead of AB, substitute DP. DP by DE is equal to, instead of AC, substitute DQ. DQ by DF. Okay, dp by de and dq by df. So finally what I can say here, no need of proving the middle part, what we have done before, we know, right? So finally what you can say here, then the pq by converse of bpt, directly I am writing from here, converse of bpt, pq is parallel to ef. Okay, in middle if you want you can write, children, how we have done, do the reciprocal, subtract 1, you are going to get the bpt, that is dp by pe is equal to dq by qf. Okay, so by the ratios are in proportion, then what you can say, the lines are parallel. If now these two lines are parallel, what can I say, corresponding angles are equal. Corresponding angles are equal, that is angle p is equal to angle e and angle q is equal to angle f. Already we know one angle is equal, included angle is equal. So now what you can say, all the three angles are equal for the big triangle and small triangle. So what you can say here, triangle DPQ is congruence symbol, this one, congruent to triangle DPF. So finally what you can say, this is congruent to this, then this is also congruent to this, that is triangle DPQ is also congruent to triangle ABC. Okay, so these two are common, same manner, children. In the before theorem also same thing we have proved, that is triangle ABC is congruent to triangle DEF. By writing all the angles equal, I can say that this triangle ABC is congruent to triangle DEF. Therefore, triangle ABC is similar to triangle DEF. Hence, it is proved. With this, we are going to end the theorem. Once again, have a recap here. So, same manner as instead of S, but we didn't consider that S also before. Do you remember? We have taken only two sides ratio and we have proved. But here also we have taken these two sides. Same proof will be there. But here one angle is included. Okay, side, angle, side, side, angle, side. According to SA's similarity, we have proved this. So, same manner, we have taken two ratios, then substituted dp and dq, then do the reciprocal, subtract 1. We are going to get these two are by BPT, these two ratios are in proportion. If they are in proportion, these two lines are parallel. If they are parallel, the corresponding angles are equal. So now the corresponding, here you can see two triangles, no? Like that only you need to compare. This triangle DPQ is congruent to triangle DEF, where all the corresponding angles are equal. Then this triangle is congruent to this triangle. Therefore, I can say this triangle is also congruent to this. How? So, all the two sides and angle are equal, then automatically these two angles are also equal to these two angles. Therefore, this triangle is congruent to this. Finally, on comparing, this triangle ABC is congruent to this triangle DEF. If they are congruent, I can say that the two triangles are similar. With this, we are going to end our three theorems which are very important for you. Children, please understand the theorem and write at least 2 times. Okay, we'll meet in our next video. Thank you all.